you guys had solved some equation that probably looked like this. And one of the methods to solve that equation was to get rid of the fraction. In order to get rid of a fraction, you'd multiply by the common denominator. Well, what would be the number you'd multiply by in this case to get rid of the fraction? 2. So what I would do here is I'd multiply everything by 2. In doing so, you get 2x over 2 minus 2 times 7 equals 2 times 10. Getting ahead of us. Okay. What could you simplify? The 2 over 2. So you'd get x minus 14 is 10. What's x?
73.
Okay. You guys, that was one of the methods in solving an equation that had a fraction in it. You multiply by the denominator and get rid of it. Vaguely remember that? It's kind of the same deal. But now you have to get the fraction. What would be the common denominator? So if I'm looking at a 3, 4, and a 4, what would be the least common denominator? 12. So in this case, I'd multiply everything by 12. And when I multiply everything by 12, I'm keeping both sides of the equal balanced. I'm multiplying by 12 on one side and multiplying by 12 on the other. Now, I'm going to show you guys a couple different ways of doing this. Distributing it out the long way, or cutting corners by just pulling pieces from it. Either way works, whatever you feel more comfortable with in the long run. If I go the long way, I'm going to get 12x over 3 plus 12x over 4 equals 12 times 7 over 4. Now this comes into the idea of what you were getting at, Vicnet, about the when can you simplify things. Each one of those fractions is its own standalone monomial, which means I can simplify within each one of those fractions. I don't have to worry about the addition part. What can I do with the 12x over 3? What does that become? 4x. What's the next one become? 3x. And what's the next one become? What's 4x plus 3x?
7x.
And what's x? 3. And what could you do to see if you're right? Substitute that in. Okay? One of the things I'm going to want you guys to do in this, especially in this section when you're solving for x, is that you always want to go back and take a second and just see if you're right. Since you're solving for some value of x, if you're wrong, you'll know you're wrong. Okay? Plus, what happens if x is in a denominator? What could you have?
Excluded values.
You could have possible excluded values. Okay?
You've never brushed this up.
No, you're right. Let's try another one.
Yeah, honestly, give us some. Please stop.
It's not even 2:15 yet. You've got to wait a couple minutes. I want you at least feeling good about yourself before I smack all the hope and.
Mr. Murphy, come on. I'm going crazy.
Sorry. So you have x over 3 minus x plus 2 over 5 equals 2. What's the 2 over that you don't see?
1.
What I'd like you guys to do is to get in the habit of anytime you have a constant, whether it's a term or a number, if it's just by itself, there's no fraction, throw it over 1. Okay? It does kind of help you in the long run because I've seen how you guys work sometimes and you make weird ideas. Okay? Do you need a pencil?
Me?
Yeah.
I'm
Paper?
understanding this.
Oh, great. Okay. What do you multiply everything by?
15.
15.
Same deal.
No, because it's because I forget all this stuff all the time. Yeah.
if I do the same idea, if I go through the same process here, is distribute out to 15. Okay. I'm showing the longer way of doing it by multiplying through everything at first. Some of you guys are probably starting to go, well, can't I just multiply the fraction on the right or the left out by 5, fraction in the middle by 3, fraction at the end by 15?
No.
Same deal. And you're simplifying it in your head as you're walking through it. So you get 5x minus 3 times the quantity. And now it's just a two-step equation. What's x? 18.
Mr. Murphy, out of curiosity, when's the test for this chapter?
Next week.
Next Friday?
No. We'll do it before that. I'm leaning more and more towards Tuesday because we're getting through a lot of this pretty quick. Yes, ma'am. I distributed in my head. 5x minus 3x minus 6.
Oh, yeah, I just thought that it would have been, I got 2 answers.
Because he's in says a negative. Good. All right.
Okay.
Let's start putting variables in the denominators. One thing I would suggest when you have a negative value, put the negative sign to the numerator. It doesn't matter where it goes, but a lot of times it's a little bit easier to deal with when it's up on the numerator. Less mistakes are usually made. Real fast, if I'm looking at this, what value can't x be? 0. So if we solve all this through and we get x equals 0, is that going to work? No. Okay. That's what we're calling an excluded value. Excuse me.
Not a stupid answer.
What's that?
Nothing.
Anyway, that'll also be called an extraneous solution. If we get x equals 0, it was an answer, just not the right answer. That shows up from time to time. And as we get to one, I'll explain that again. What is going to be the common denominator between a 2, an x, and an x? 2x. So everything here has to be multiplied by 2x. Long form one last time. I'm going to get 2x times 4 over x plus 2x times 5 over 2 equals 2x times negative 11 over x. And each one of those individual monomials will be able to simplify out to get rid of the fraction. Yes, sir?
When you're finding a common denominator, do you also look at what's to the other side
Yep.
of this line?
Yep, because you're multiplying everything by it. So first fraction, the x drops. So we can get 8. Next one is just 5x. And it's going to equal negative 22. Subtract 8. You get x is 6. All right. Remember, you have a calculator with the fraction bar button. You can always go back and double check, make sure you get the right answer. Okay?
This is some crystal clear math.
Boo. It was a very clever video. Okay. So we have 5x over x minus 2 equals 7 plus 10 over x minus 2. When I'm writing the problem down, what should I put 7 over? 1. Just to kind of remind yourselves. What's going to be the common denominator that I want to multiply everything by?
X minus 2.
X minus 2. Now I'm going to shortcut this a little bit this time. Do I need to multiply the first fraction by the x minus 2?
No.
Because if I did, it would just drop out anyway, wouldn't it?
Yep.
Okay. Does the next one need it?
Yes.
Does the last one need it?
No.
Because those terms within the monomial of each one of those monomials would have dropped out. So you're going to get 5x is 7x minus 14 plus 10. You get x equals 2. But wait! Does x equal 2 work?
No.
Because if you substitute, you can't divide by 0. This is what you call an extraneous solution. So this problem has no solution. It's no solution. 2 would be considered extraneous. It's an excluded value. It's an answer, but it's not an answer. Yes, sir.
Why does that happen?
It just does.
Okay, but then doesn't that mean that the equation isn't correct?
No. It just means it's an equation that you can't solve. That's all it means.
That was like an equation for a building stuff. They need to know how to build it.
I don't know. I would hope that they wouldn't try to do that.
There's no way to build this.
We missed you. No, you didn't. Okay. So another one. Sometimes, when you go to start to write down the problems, just like we did earlier, you're going to want to factor denominators. You might want to factor numerators. You want to factor them as you're going, because that way it's going to be easier to see what your common denominator is going to wind up being. Very similar to what we did in 9.5 for a few days. Every denominator we try to factor. We try to factor everything we can to look at our different terms that we'll wind up with. It's a nice pattern to get into. Okay? So 4x plus 1 over x plus 1 is 12 over x squared minus 1, all plus 3. What do I have to factor here? And what do you get? Good. So hopefully when you guys wrote this down, you wrote it as this over x minus 1, x plus 1. Right? I hope. Okay. What are you going to multiply everything by to get rid of the fractions? What's going to be the common denominator? X minus 1, x plus 1. I'm going to multiply it by the common denominator, which would be x minus 1, x plus 1. Fraction on the left needs what? An x minus 1. The one in the middle, does it need anything? No. The one on the end, what does it need? It needs both. And what was x minus 1, x plus 1, just to make our lives easier? I had to multiply it by x squared minus 1, so I might as well just distribute it and be done with it. Okay? That's where I'm getting that at 3x squared minus 3. I just took it that one extra step. What do I have to do on the left-hand side?
Boil, yeah.
4x squared minus 4x plus an x, I get minus 3x minus 1 equals 3x squared plus 9. No, why bother? You have to solve for x. You have to set aside equal to 0. Whoa, what's wrong?
I think I see it, but
Where did I get 3x squared minus 3?
Yeah.
Okay. I should have realized that I did this first or third hour too. Okay. Here you had to multiply by 3 times the x minus 1, x plus 1. Well, x minus 1, x plus 1 is x squared minus 1. I just distributed, I just I skipped a step, okay? That's all I did. I simplified something quicker. Set aside equal to 0. Which side are you going to set equal to 0? The left or the right? Right. What times what's negative 10? You add together to get negative 3. Negative 5 and 2. Very good. Which gives you zeros at 5 and negative 2. And now all I have to do is double check to see if they work. Okay. Completely forgot the first part. First part was what? 4x plus 1 over x plus 1.
Equals 12 over x squared minus 1.
So if I use 5, I get 21 over 6. Does that equal 12 over 24 plus 3? Well, that's 1/2 plus 3. This is 18 over 3, so this is 3.5. Isn't that 3.5? Yes. 6 goes into 21 how many times? 3. How many are left over? 3. 3 over 6 is that. Negative 2, same deal. Try it with negative 2. You get negative 8 plus 1 is?
Negative 7.
Negative 2 plus 1 is?
Negative 1.
Okay. 12 over 4 minus 1.
3,
4.
4.
Did they both work?
Yeah.
Guys, what I'm saying here is you always want to double check your answers. Make sure they both work. One might work, the other one might not work. Okay, you might wind up with an excluded value thrown in there. Okay, that kind of stuff.
Wait.
Yes, sir.
So you're saying, when we get the answers, we should plug it in to the top?
I would say you would substitute.
Substitute.
Yes.
Is
Yep,
it-
always,
All right,
because
so-
you're going to check for your extraneous solutions.
Hey,
Okay.
would it be possible to get extraneous solutions with prize over that? Where you,
The two of them?
yeah.
Yeah, absolutely, absolutely. It does happen from time to time. Yes, sir.
So why are you so against the word plugging in as opposed to?
You find me in a math book that says plugging in.
I'm sorry, the only reason I say it is because like all of my math teachers have always said,
Oh.
oh, plug it in.
Well, we're gonna, buck the trend.
I was just curious if there was a technical reason why you said that, or if it was just.
There's no math property that says. There's no math property that says plug it in.
Okay.
If I have a college math teacher that says plug it in, I'm going to mail you a letter saying,
Now, we get to this part here, believe it or not, this example should be the easiest. Here's why. What would you do if you had to do this? You would cross multiply because it is fraction equal fraction. It's a ratio. Very good. Isn't that the same darn thing?
Yes.
Yeah. It's a fraction equal fraction. Since there's nothing else tacked onto either side, there's no plus 4 or minus 6 or anything. It's just one fraction equals some other fraction, some ratio. We just cross multiply. We get 2 times x minus 1 equals 1 x squared minus x. Distribute and set one side equal to 0 again. Subtract the 2x and add 2. 0 is going to equal x squared minus 3x plus 2. What times what's 2? Add together to get negative 3. Negative 2, negative 1. which gives you zeros back at
2 and 1.
2 and 1. Very good. But I need to check.
Yeah, check.
If I substitute in, I use 2. I get 2 over 4 minus 2, which is 2. I think, right? No, it's 1. Ah. Does that equal 1 over 2 minus 1? 2 works. And 1 doesn't. You can probably see that right away.
1 minus 1.
And will that work?
No.
So you were asking earlier, will you get sometimes an excluded value within a quadratic? Yes. Sometimes that happens. And that's the whole point of going back and checking for the extraneous solutions. You always go back and resubstitute it and see if you got your answer right. Because anytime you're solving an equation, you should never get that wrong. Because you can always go back to see if you can substitute in. So,
He's not the sharpest of
Cooper, do you listen to yourself like ever? It's a joke. Can you just ever hear you were thinking enough?
last one, you do it. So you're going to get 6x minus 12 equals x squared minus 3x plus 2.
Yep.
Wait, move it all over. We're going to get 0 is x squared plus, minus 9x plus 14.
Yep.
Minus 7 minus 2.
2 and 7.
2 and 7. Do they both work?
No.
7
Yeah, they do.
What?
Yeah, they do.
Yeah.
What's 2 minus 2?
0.
What's 0 divided by 6?
0.
What's 2 minus 2?
0.
What's 2 minus 1?
1.
What's 0 divided by 1?
0.
Does 0 equal 0?
Yes.
So they both work. Now, if it was x minus 2 in the denominator, then you'd have to throw it out. 0 could be up top, just not down.
I would be confused by that part. Which one's like undefined and which one's zero?
Tangent graphs are going to be fun with you.
Tangent
96, I forgot what page number it was. Let's see, it starts on 571. Do 30 through 50 evens, please.